So far, we already have two centers of the triangles. What are they? Circumcenter. And incenter, right? What is a circumcenter? It's where... Oops. That's going to be the characteristic, but how do you find the circumcenter?
Find the perpendicular bisector.
It's where the perpendicular bisectors meet, right? It's where the perpendicular bisectors meet. And what's the characteristic of it?
It's the same distance from every angle.
Same distance to the points. Or it's a way to inscribe the triangle into a circle. Right? Yes?
Yes.
So basically, circumcenter, you're given a triangle. You find the perpendicular bisectors of each one, right? Yeah. What was the easiest way to do that as far as if we were going to construct? If I said, let's construct perpendicular bisectors, how did we use the compass to do that? Make sure it's more than halfway. Oops, undo.
Which one is
This is the circumcenter. So you put your point at a corner, right, at a vertex. Make sure it's a little bit bigger than halfway, right? And then what? Come on. Good? Nice color. Okay, now what do you do? Go to the other side. We'll swing that around so I can grab it. Over here. Put it at that point. And then really you just got to cross those, right? Yes? So then what do you do? Connect the dots. Draw a line. Connect the two dots. And that is going to be a perpendicular bisector. Yes? And not really knowing where it's going to be, we can extend that line. And then we just got to do it again, right? So we grab this, make sure it's a little bit more than halfway. You don't want it. Why don't you want it real big? Yeah, they will cross each other, but they're going to be kind of way too big, right? So grab that, go up to the other side of that line, cross both sides, and then all you have to do is connect the dots. Yes?
Yeah.
Now, do you have to do all three?
No. Well, you should.
You should. Why should you do all three? Make sure it's pretty accurate. But when in doubt, to test your accuracy, what's the easiest way? You should be able to open that up to any one of the 3 points to where it intersects there. And if I did it correctly, that's not the color I chose you told you to do. Well, did it work? I'd say it worked pretty good, right? Yes?
Yeah.
Make that color. Yes? Works pretty good?
I can see it.
Good? Questions?
Why?
Circumcenter? In case you want to inscribe a triangle inside a circle.
Does it do anything real for math? Like, is it?
Yeah.
Sure.
Does it help you like with other things?
We have this conversation. I'm going to.
Well, I mean, there's lots of examples. I'll give you one for, how about for in-center? Let's do in-center first.
Because like, there's obviously a reason you have to teach it. Because you're not just going to teach you something you don't have to do with.
What's an in-center though?
Angle
The
bisector.
angle bisects.
Okay. This is where the angle bisectors intersect. Okay. Now, a simple example of a a reason why in real life you may need to find something like this. Maybe you're a farmer and you have a garden that's shaped like a triangle, and you have a sprinkler and you want to make sure you water all the everything, right? You're going to water some grass over here too, but you got to shoot the water to where it hits all the corners. You put the sprinkler at the in-center. You're done.
What if you can't give a triangle garden?
Well, you could.
Who has a triangle garden?
Just because you said that, I'm going to have a triangle garden.
There you go. Make a triangle garden, and you can water your garden by putting the sprinkler at the in-center. Huh? Just trying to come up with examples. Alright, so what's the characteristic of an in-center?
It's the center distance from all the sides.
So this one's going to be a way to inscribe a circle inside a triangle, right?
This is for a circle garden.
Well, I'll give you an example. Well, let me draw it first, and then I'll give you an example of how you can.
Oh, yeah, triangle sprinklers.
Well, I want.
3 different sprinkler systems.
Let's do white.
One in each corner.
Alright, so we'll draw our triangle. So how did we construct the in-center?
Put it on the point.
Yeah, put it on the point.
And then you make a hash in the middle.
What was the first thing we had to do?
Make it longer.
Make it longer?
Make
Make it shorter?
Yeah.
Make an arc.
And make an arc just that goes through both lines?
Yeah.
That's not the color I picked. What just happened? Okay, now what?
And then you gotta do one outside the triangle.
Now what do you do?
Now you put it on point.
Put it on the point of intersection, and then you make an arc through the middle. Yeah. And then do the other one. And do the same thing. And then draw a line. Okay. Yes? And then we gotta do it again. Come up here. Make an arc. We can make it a little shorter if we want to. Make an arc. Come down here.
Are we going to need to be able to do this on anything?
Maybe. Cross that. Come over here.
Oh, what?
Cross that. And then
That's a lot of lineage.
draw through your X. Now, should I do the third one? Yes. But what also should happen if I put this at the in-center? I should be able to make that to where it just barely reaches. And it should why won't that change colors? I don't know why that won't change colors. Whatever. Alright, so it should reach through. Now, a basic example of where you could use this. Maybe your backyard is the shape of a triangle. Okay? And you have a dog fence, right? You want your dog to be able to, you have one of those electric shock collars that has they're not one like the invisible fence that you bury in the ground, because those are expensive. So you buy the one that's just got the tower, and it sends out a signal so the dog has like 30 feet to run in any direction, right? Well, you don't want your dog to leave your property, so where do you put that post or a chain to where the dog has full access to much of the it's got to be a circle.
He's allowed to stare long.
Right. Yeah.
Okay.
Okay.
Or like all weekend where you're like, Hunter's going to ask again, I need to figure
No, I just came up with these top of my head. So there's probably other examples. You know, I probably could have came up with some better examples, but these were just off the top of my head.
Like a pool and a triangle house.
Sure.
Everyone has triangle houses.
Kind of cheaper just trade
Now,
dogs.
or, okay, here's another actual example, okay. You have,
How many yards have you seen in your life?
A lot.
I'll try to draw this semi-precisely. All right. Oh, that's, we'll do this. All right. So you have this house, right? I want to put a window. There, not all windows. I want a circular window, okay? I want a circular window in that area, but I also want it to make sure it's centered, right? So, where do I place that center of that circle? An in-center would be one of the options. Okay?
Measure out.
Or you could just take it again.
Yeah, that's basically what it is.
Easier way to take away the guess.
Or just like
Go ahead.
be a perfectionist.
All right. Some new terms. I know. I try to come up with a real-life example, and as soon as I come up with anything, they just throw me under the bus.
I see a lot of triangle houses, gardens, and yards.
No, you don't.
I feel like you have one.
Yeah. No, I have a rectangle yard actually. It goes back.
All right. So, median of a triangle. Guys, let's get through this. So, what a median of a triangle is you will find first the midpoint of one side. Okay? Yes? Well, we'll talk about constructing in a second. And then the median, before, when we found the perpendicular bisector, it'd be a perpendicular line through here. Probably would not hit this point, right? The median of a triangle is simply a line that connects the midpoint of one of the sides with the opposite vertex. Make sense? So far, so good?
Yeah.
How many medians does the triangle have? 3, because it depends on which side you do the midpoint. So that would be one median. If I wanted to find this median, I'd have to find this midpoint, right? And then I would connect that point with that other vertex. So far, so good? Both of those are medians? Okay. If you do that to all 3 sides, so now this side midpoint, yes? And I connect that midpoint to that, they should intersect at one location. That point is what we call a centroid.
Do we need to know how to do both those methods?
Well,
It's the same as this.
when this is all said and done,
It's just
a long time ago somebody asked, what's the center of a triangle? Well, if I say find the center of a circle, that's a pretty easy idea, right? There's only one center of a triangle, or a center of a circle. There's only one center of a square. But when it comes to triangle, if you say what's the center of a triangle, that's a much more difficult question to answer because there actually are 4 different ways to find a version of a center of a triangle. 2 of them are, you can do circumcenters and we can do incenters. That's a way to find a center of a triangle. But a centroid is another one. And all it is the intersection of the 3 medians. Okay? Make sense? All right. Real quick.